Hello everyone and to Sobit. So I'm thrilled to introduce my first guest on TikTok Live, Mr. Sobit Pradhan, who is also my PGT classmate from Samsi College of Education. Now Sobit is a dedicated physics teacher at Timshing Higher Secondary School. He earned his master's in education in physics from SE last year, where he received the Academic Excellence Award and holds a BSc in Physical Science from Sharatsi College. Now, I have been closely following Sobit's impressive work through his social media accounts. So, his commitment to STEM is evident through his role as STEM club coordinator, and he was also a former astronomy club secretary. His research has been featured in the Journal of Educational Action Research, and he's also actively involved in exciting projects like Project Phenoptes and the Fab 23 Bhutan Challenge. And most notably, Sobit has pushed boundaries this year by becoming the first Bhutanese selected from thousands of applicants to attend a prestigious workshop at CERN in Geneva, Switzerland, representing Bhutan on an international stage. So I requested Sobit to share his unique experiences and insights from this remarkable opportunity at CERN with the hope that it might help many educators in Bhutan. So, welcome, Sobit. It's a pleasure to have you.
Thank you so much, Vicky, for your wonderful introduction. And it's pleasure meeting you after such a long time. I think
Long time.
long time, maybe like 6, 7 years, right? So thank you
Yes.
for this
As
invitation.
Yes, unfortunately, we can't see your face. So I think we need to follow Sobit to get like 1,000 followers. Okay,
Yeah.
so I will start with a question. So you might have seen Soviet. I recently ran a poll on my social media, asking people whether they have heard about CERN, and then many people mentioned that they hadn't heard of CERN. CERN. So could you enlighten us about what CERN is and its main goals?
Yeah, thank you. So basically, CERN is the European Organization for Nuclear Research. Actually, the word CERN, its
Mm-hmm.
full form is in French, but in English, it is actually European Organization for Nuclear Research, and it was founded after the World War II, whereby all the European countries they wanted to join together and make a huge laboratory for scientific research, mainly for the nuclear research. And it was founded in the year 1952.
Mm-hmm.
And the main goal was to
Mm-hmm.
know about the universe, the fundamental particles which in a way helped in making the universe, how the particles react, and there are many applications uh, due to so many discoveries made by CERN. And this HST, International High School Teachers Program, is organized by the CERN, whereby teachers from all parts of the world come together to share their knowledge, pedagogy, and in a way we learn how the LHC works. And yeah, that's it.
Okay, so thank you, Soviet. Yes, I also looked up about CERN, and then yes, like you said, it was started during World War II. So I didn't know that CERN was actually in French. Now that you mentioned, it's actually a Europeans, the Union. They came together, and then they wanted to know about the universe, like the how Big Bang theory and all. I think
Yeah,
that is supposed to do with that. And I also
right,
found out that they have CERN is home to the largest particle collider called
right,
Large Hadron Collider. Yes.
right.
So, can you please explain us because I think this topic, I think it will help chemistry as well as the physics teachers in Bhutan. So, can you please talk about this, the particle collider, the biggest in the world, which is there in CERN?
Right. Sure. So, Large Hadron Collider, it is placed underground. It's like a 27-kilometer tunnel. And basically, how it works is it works through various accelerator. At the initial phase, it moves through the linear accelerator in order to give
Mm-hmm.
push to accelerate the proton. And the proton,
Mm-hmm.
how they get proton is from the hydrogen. So from hydrogen, they
Okay, so
extract the proton. Yeah, from the hydrogen, they
uh-huh.
extract the proton, and this proton is then they send it to the linear accelerator called as LINAC. Then after that, it
Mm-hmm.
gains its speed, it gains its acceleration, and it is passed through the proton synchrotron, which is not linear, it is circular. And after that, again, it gains
Yes.
more speed, more acceleration.
Mm-hmm.
Then there is one more synchrotron called super proton synchrotron, and again there's a
Mm-hmm.
circular accelerator. And after that only it reaches to that 27-kilometer tunnel. That's called LHC. And you can imagine that from this
Okay.
accelerator two side, like billions of protons from one side and from another opposite side, billions of protons. They come together with almost at the speed of light,
Mm-hmm.
and they
Mm-hmm.
clash. Uh, they react with each other, and while doing so, they emit particles, and that's how the
Mm-hmm.
scientists detect different particles, be it you can say quark or muon, all these fundamental particles. And one thing is
Mm-hmm.
within the LHC, there are four detectors, and they are used for
Mm-hmm.
different purpose. First is very well known CMS, compact muon solenoid, which is mainly used to know about Higgs boson and the dark matter. Another is
Yes.
Atlas, same. So Atlas is bigger than CMS, but its function is also same to discover Higgs boson and dark matter. Then we have this one LHCb. So LHCb is more for knowing about antimatter, and the last one is LHC,
Mm-hmm.
that is more for plasma. Uh, Plasma, which was to know about, like it is said that right after the Big Bang there was release of plasma and all. So to know more about that.
Mm-hmm.
So these are the four detectors
Mm-hmm.
which helps the scientists to know about different fundamental elementary particles. So in short, that's how it
Wow.
works.
Wow, it's quite fascinating, right? We just talk about there is something called protons in during our chemistry or physics lesson. So to have you gone there and then seen this in real, it's really fascinating from my side. Now that you mentioned about your workshop, which was international high school program, so can you please take us? What was this workshop about, and about your selection process? I think all the educators who are watching right now, I think they want to know how did you first learn about such program, because I think this is not a government initiative. I think
Right.
you went there and then you look for opportunities on your own, so which is incredible, by the way. So can you please tell us about this workshop?
Yeah. Yeah, you're right. It's fully through exploration. Yeah,
Yes.
just I would like to tell how I came to know about the sun. It's not like it happened last year, but the word sun actually I came to know a little bit about LHC from the YouTube videos back in
Mm-hmm.
my early phase of my teaching career. Like, well, I have to explain the very complex topic like Big Bang Theory, black hole, and all to my students. So while doing so, I came to know a little bit about LSC from the YouTube. Then through that, my curiosity grew about in knowing about the universe, how we came into being. Then back just in the year 2021. Royal Society for STEM. They organized
Mm-hmm.
this virtual tour of CMS, whole Bhutan. So through that,
Mm-hmm.
me and even I showed to my students how the CMS looks like. So that time, I think that was the first time I thought maybe in future I should be there. Maybe I might get the chance to visit there. Then it
Mm-hmm.
was only when I went to for master's course there, as you
Mm-hmm.
uh, I worked side by side. I worked with the project benefits, and
Mm-hmm.
thereby we made this robotic telescope. And my mentor of the project benefits, Mr. Joe Weiss. So he was the one who said that there are some opportunities in CERN. Why don't you apply it? So that's how
Okay.
then I explored more on the about the websites of CERN. Then I saw that there is a program called International High School Teachers Program, which happens every year,
Mm-hmm.
and this is for the
Okay.
international teachers. Mainly it
Mm-hmm.
targets physics teacher and even chemistry also, and even the it
Mm-hmm.
can be from computer background also, and thereby
Mm-hmm.
I
Okay.
applied. So I think it was January first week. Yeah. So I applied,
Mm-hmm.
and so basically you have to write all your. You have to give your CV, all the qualifications, what, and there are some questions related to particle physics which you have to answer,
Mm-hmm.
and there were also questions related to how this what you call workshop will help in our curriculum. So that one,
Okay.
and yeah, even though I was asked to make a video why I am interested in taking up this workshop, and that
Wow.
I have to do like within 2 minutes. So within 2 minutes,
Wow.
2 minutes video. So I have to
Mm-hmm.
explain what is my motive, what are my interests, why I want to join this workshop. So yeah,
Mm-hmm.
I sent the video. Then I had to wait like for 3 months. I think we got the. I just tried. I never knew that I will get it through, but in the month of April, I think, so I got the email that I'm selected. So the
Wow.
interesting thing
Mm-hmm.
here is that there were like thousands of applications, and from
Yes,
there,
India.
how many? 48 teachers from all around the world were selected. So it was a proud moment for me.
Yes. So, like I said, you are the first one from Bhutan to actually grasp this opportunity and actually try. And then it was really fortunate, lucky for you to have been accepted there, which is a great thing, actually. Like I was saying to my other friends, now you have paved way for other physics teachers to actually apply for CERN. Who knows? Other physics teachers might also be selected. So yes, I saw it. I wanted to ask, since you were selected from thousands of applicants, now how did you feel to experience being there in person?
Uh, so at first, when I reached there, it was a surreal feeling for me. I didn't believe I was
Mm-hmm.
there. I still felt like it was a dream, and
Mm-hmm.
like going around every day was a new experience for us. There were a lot of surprises and full of excitement. I met a lot of friends from all around the world. So and again, getting the lecture from the renowned scientists, physicists, theoretical experimental physicists. So
Mm-hmm.
that really enhance my knowledge in particle physics, which
Mm-hmm.
I didn't know before. So it was really a surreal feeling for me, which I think it was a great opportunity for me. So I'm thankful to the God.
Yes, indeed. It was really good to see you. I saw your social media posts, and then I was wondering where you were going. So I heard about CERN when I was during lockdown. I was nominated for that, but it was online, unfortunately, and I have little bit knowledge about CERN. So I was really happy to see you go there in person. Now that you mentioned that you met some physicists, and I think you also met some scientists there
Yes,
and
yes.
educators from different countries. So, did you notice any differences in approaches to science education while you were interacting with these educators there?
Yeah, like while discussing with them to the teachers from other parts of the world, I noticed that one of the thing like they focus on real life applications, and like
Mm-hmm.
from the young age itself, the students are given the hands-on activity to know more about the physics or even the chemistry. And another
Mm-hmm.
thing is like more of uh, out of the box questions are given for the
Mm-hmm.
students to think, and the students are they have to work more in group activities, and there are some schools in other parts of the world whereby the students from the young age itself they are they uh, they are involved in making experiments related to particle
Wow.
physics or even the small,
Mm-hmm.
even the chemistry experiments. And one thing that was really another different thing was some of the teachers they said that they teach both chemistry and physics. It is one. Out here, which is like separate. Physics teacher is
Separate,
different,
yes.
chemistry is different. But there, it is same. So it's like physics, chemistry, one. So and
Mm.
they had like uh, I don't remember physics, physics one, physics two. So whereby chemistry is also infused. So in that way,
Wow.
their curriculum was quite different. Another thing is particle physics in Bhutan. In our curriculum, it hardly starts from class 12, but
Right.
but there it's like
Mm-hmm.
it starts like from let's say class 9 onwards on class 9, 10.
Wow.
So you
Mm-hmm.
can see there are a lot of differences, and I could learn from them also. That and while going there, some of them were already experts in the particle physics. For me, it was quite new. So yeah,
Mm-hmm.
and we had that the good. We learned more because we had that study group discussion. Study group. So
Right.
every day we were divided into groups such that like in my group how many there were four members, one from Pakistan, then uh, one was Hungary, England, so like that. And every day whatever we have learned we have to discuss. There will be some questions for us to
Mm-hmm.
discuss, and the next day they will we have to present in the class. So it was quite challenging, and we learned a lot. Yeah.
Mm-hmm. Yes. So yes, I think it was a good opportunity for you to make friends, and then I think in future you can collaborate with these friends, and then I think it will be an exciting journey for you. So, like you mentioned, Soviet, you said the way they teach there in other parts of the world, they focus on real life application, and then teachers they think about giving out of the box question, and they deal more on hands-on activity. So, do you think, Sobit, those teachers who came from other parts of the world, I don't think they have resource constraint like in our country. So, do you think, what is your thought on this? Whether because of a country we have resource constraint, our government can't really afford all those big machines where we can teach about particle physics and all. What is your thought on that? Whether being a resource constrained country is not allowing us to move forward, and then uh, I feel that we are still following the traditional way of teaching. So, what is your thought on that?
Uh, that to some extent, yes, there are resource constraint in our context, and we do feel like, well, even to do simple experiment, we do not have enough materials in the lab. But having been to CERN, I realized that it's through collaboration that we can, um, do much more. Like though they have this large hadron collider, obviously, at what they said is they have given some of the resources in the website, and there are some like Lego system like CF for the CMS or LHC, whatever. So they said that why don't you make a 3D print of this CMS and you can use it to teach your students. So yeah, in our country we have Fab Lab, so it would be a
Yes.
better, good idea if we can make some Lego type 3D print of this simple this accelerator and make use of it in our class, and that way the student can learn better. They will see it how the LHC is, though not in real, but at least they would feel it,
That will make.
the 3D printed one. So I think that could be one of the way, like Fab Lab should be, the educators like us and the Fab Lab should collaborate, and maybe in future all this 3D printed TLM can be available for all the teachers in school. Another thing, uh, like there are other opportunities also. Like Bhutan is right now non-member of CERN, so that's why most of the opportunity we do not get most of the opportunities. If we become at least associate member or maybe the member of the uh, CERN, then more opportunities will be there.
So, how can what is the criteria to become the member of CERN? It has does the government official need to talk with them, or do you have any idea on this?
Yeah, they mentioned that obviously the government have to take interest uh, in them, and they have to give the proposal. Yeah, and they were also like the member state it would be difficult because the member state they actually fund the sun. There are like 40
Oh,
countries,
okay,
I think, which fund uh,
CERN.
the sun, and associate members are also there, which includes India, Bangladesh. So they are associate members. So maybe in
Oh.
future, if we can collaborate with associate members, maybe India, so maybe we can get more opportunities.
Otherwise, it would be exciting, right? I think we can have all those opportunities if we could become even the associate members. So
Yeah.
besides Large Hadron Collider, did you see other advanced technologies or instruments, or what did you learn at CERN?
Okay. So there were various topics that we learned, starting from particle physics, how another thing, particle accelerator, detector, how LHC runs, and how the Higgs boson was discovered. So some very exciting technology that I saw was like superconductor, superconducting magnets. Yeah. So which I only knew in theory, but the main thing which runs the LHC, one of the main item is the superconducting magnets. So throughout this LHC, there are like 2,200, I think, 2,200 superconducting magnets. And interesting thing here is this superconducting magnet is it the conductor becomes superconducting material when it is cooled at like minus 271.3 degrees Celsius, which is almost near to the ideal gas temperature. So you can
Uh-huh.
see how the chemistry is connected here.
Right.
So it's amazing to see that the human, the scientist, is able to reach that much cold temperature. So ideal gas, is just based on assumption, but like in the LHC, the superconducting magnet is, the conductor becomes superconducting at minus 271.3 degrees Celsius, and it is kept at that liquid helium, superfluid liquid helium, which is of cold temperature. So one was that. Oh, another technology that I saw was during that collision part in that
Mm-hmm.
LHC, they said that 40 million photos per second are taken of the particles. Just in 1 second, 40 billion photos are captured by the detectors of the LHC. So that's
Mm.
insane engineering science involved here. So
Yes.
that was really fascinating for me. And
Mm.
they said even in within nanoseconds, some millions of collision would be happening. So that's like lesser than blinking of our eye. So within that
Right.
lesser than blinking of our eye, so many collisions would be taking place, and that is being detected by all these detectors, and which is then fed to the computer system, computer
Mm.
grid system for further analyzing. So that was fascinating.
Right. Wow. So, yes, it's quite fascinating. Like you said, 40 million photons per second. Wow, we can only imagine. So, I'm glad that you went there. At least you know, like photons and all. You can really talk to your kids. I saw this, and because you have that experience. So, my question now is, besides this, are there any specific concepts or experiment that you think would be valuable to introduce to students because of experience at CERN?
Okay. So we were introduced to some of the workshops like cloud chamber, which was very interesting, and I think we can make uh, build our own cloud chamber to teach students
Mm-hmm.
about particles. So basically, uh, in this cosmic race, we are surrounded by some particles, be it proton. So this we can see its traces through the cloud chamber. And how we can make is quite simple. We just have to make use of the uh, isopropyl alcohol, or maybe ethyl
Isopropyl.
alcohol.
Yes. Mm-hmm.
I think it's a metal box is needed,
Mm-hmm.
container, and in that container we have to use dry ice. Now, dry ice we
Right.
can get from
Yeah.
either the fire extinguisher if it is can, if it's not using,
Mm-hmm.
we can use that, or in place of dry ice, we can also
Mm-hmm.
make use of ice also, but we have to
Right.
mix it with salt. So I watched in YouTube, so that can be another alternative. So I'm thinking of doing that
Yes.
when I introduce the particle physics topic. So
Mm.
that's a simple way. So we have to keep our room dark. Then, due to the reaction of that ice, which is that time it was minus 80 degrees Celsius, dry ice. It
Mm-hmm.
was so cold. That dry ice and the metal, we will see that some traces of particle moving, and some we'll see what we saw was some particles, it was moving straight and some were moving a little bit spiral, and through that we
Mm-hmm.
can know whether it is electron, proton, muon, and maybe positron. So there are some properties how it moves. So that is one of the activity I think which you can do in our class. And another thing in physics, which I have already started, like I'm teaching superconducting magnets,
Mm-hmm.
superconductor in class 12. So I'm using some of the resources that CERN has provided to teach
Wow.
some of the topics. And interesting thing about the LSE is the main principle which was used for this Large Hadron Collider is electromagnetism, electromagnetic induction, Lorentz force,
Mm-hmm.
and all these topics are already there in class 9 physics. So that's
Right.
what I have been telling to my students that whatever you are learning is not only theory. There is a huge application, real life application. So in the obviously I cannot teach the LHC in detail because it's not part of the syllabus. But what I'm trying to do is some small portion like electromagnetic induction, Lorentz force, superconducting magnet, or maybe the cloud chamber.
Mm-hmm.
So a small portion. In a way, I am trying to mention what CERN is doing, and in that way, connecting to our syllabus also.
Right. So I can't wait to see your cloud chamber soon, Sobit. I know you are a STEM coordinator there. So we
Yeah,
also have in our school, Dampu Second School, there is a STEM club, but I'm not the member of that one. So maybe they will be able to learn from you how to make this cloud chamber.
yeah.
Yes,
I
so like you
can I
mentioned,
can share you the
yes.
link. It's there in the YouTube also. The
Oh,
cloud
okay,
chamber.
okay, the cloud chamber. Yes, so like you mentioned, so with so whenever I teach chemistry, my students like, where am I going to use this topic? They always ask this question. Ani ki use kachina madam lappe navana se kate use bini na simu. They always ask this
Yeah,
question, but I
yeah,
will say there will be a time one day when all this will make sense. You will know why you are learning all these things. Maybe because our
yeah,
country is small and there is resource constraint, but like you said, when you went to Switzerland, CERN, you knew, okay, all those things are there, is where it's being used. So I think business students, they have to, yes, they have to ask question like, where can we
yeah.
use this one? So in a way,
Right.
yes, everything we learn, there will be a time when we will be able to use all these laws and Lorentz force and all this, like you mentioned.
Yeah.
So
Right.
based on what you learned at CERN, where do you see the future of particle physics research heading, and what role do you think CERN will play in that future?
Uh, so Sun has been playing a big role in discovering many particles, and
Mm-hmm.
just to name few, like you may be knowing about the Higgs boson,
Higgs boson,
and
yes.
yeah, and related to Higgs boson, because of the discovery of Higgs boson, there are new discovery coming in line. Like there can be more
Mm-hmm.
discovery because of the discovery of Higgs boson. So
Mm-hmm.
before the discovery of Higgs boson, there was the question like why the particles, how the particles get mass. But
Mm,
with the
yes.
discovery of Higgs boson, we now know that the particle has mass because of the Higgs boson. There's
Higgs
a Higgs
boson.
field, and yeah, it interacts, and this Higgs because of the Higgs boson, the particle has some mass. And now the scientists are trying to further see the impact of Higgs boson, how it perfectly fits in the standard model of particle physics.
Mm-hmm.
Basically, in the standard model of particle physics, it includes the four force, strong and weak nuclear force, electromagnetic force, and gravity. And the problem in the standard model physics is the gravity we cannot explain. The standard model is not able to explain gravity. And now they
Mm-hmm.
are saying that by doing more research on the Higgs boson, there is possibility that uh, through further research and through further uh, acceleration, there's a possibility that they would be able to find theory of everything which fits all the forces. At the moment, we cannot explain gravity. Like Einstein talks about the theory of relativity, but it doesn't fit well with the standard model of particle physics. So they are uh, researching on Higgs boson, and there is possibility that in future the scientists would know about the dark matter, dark energy,
Yes.
and also
Mm-hmm.
the why there is symmetry, why there is anti-symmetry. Like when there was a Big Bang, it is said that uh, matter and antimatter was formed equally. But
Mm-hmm.
somehow matter was more than the antimatter, and somehow the antimatter got vanished, and all we have at the moment is just matter. So why that happened? So they are doing research on that also. So there are many applications, uh, and one of the very good applications of this LHC is in the medical application field. Medical, there are many
Right.
applications in medical field. To name few, there is PET, positron emission
Yes.
topography, which is used for the cancer treatment. And due to the discovery made by LHC, uh, the medical field, they are also making this flash flash radiotherapy. That's the new. In future, it might become true. So they are working on that flash radiotherapy, which says that this
Mm-hmm.
radiotherapy will happen within milliseconds, so that there won't be
Wow.
much uh, damage to the cells and all, and the patient won't be have pain and all. So that is one. Another thing that they are working on is the CERN is trying to make again a bigger collider. It's called FCC,
Wow.
Future
Mm-hmm.
Collider, Future Collision, and but it's at the moment it's in the initial phase. Uh, they said that it would be like around 91 kilometers
Wow.
at CERN at Geneva.
Uh-huh. Right.
LHC right now is 27 kilometers. So
Yes.
they
So
want
are
to
they
make
going to extend
FC.
on this one, or are they going to completely build a new one, new collider?
Yeah, it's kind of a new one because
Oh, so
the
they're going to
main
keep the current one? Oh, okay.
yeah, yeah.
Wow.
The main aim of the LHC was to find the Higgs boson, which they have
Mm-hmm.
done, and now, in order to find
This is
the dark matter, dark energy, which is very difficult, so they said that
mm-hmm.
more acceleration is needed, more precise
Right.
instruments are needed.
Oh.
So
Uh-huh.
maybe in a decade or so, we might see FCC also. So
Wow.
there are
So it's
many
going to be huge,
things.
91 kilometer. Wow.
Yes.
Mm. Wow. So I believe that CERN is also where our web page www that one was
Yeah.
also initiated, right?
Right. Right.
Web page,
You
yes.
correctly pointed out. Yeah. We took picture in that place also. There was yeah, worldwide web server. So it is placed in
Yes.
that science gateway, whereby there is the
Mm-hmm.
exhibition. Uh,
Mm-hmm.
so due to the LHC, LHC was proposed. I mean, it was the first experiment was conducted in the year 2008. So before that, in order to make such a huge collider, they need collaboration of all the scientists from the world.
Scientist.
So
Mm.
because of
Mm-hmm.
that, it led to the
Creation,
introduction
yes.
or the development of World Wide Web,
Worldwide
internet.
web.
So in a way, Sun plays a pivotal role in development of the internet also, because if there was no internet, if there was no server, then there couldn't have been the collaboration of so many scientists working on
Scientist,
this
yeah.
LHC. Yeah. So that was one of the development.
So currently, Sobit, do you have any idea like how many scientists are working at CERN at the moment?
uh, it was like about more than 3,000.
More than
But
3,000. Wow.
yeah, but it's like this. At Sun, it would be hundreds, but they are working remotely in different countries. So that's how they work. At the Sun, there would be some hundreds, but there are scientists who will be analyzing, who analyze the particle detected at sun, particle which is detected by the LHC. It is being analyzed by the scientists all around the world. So if I have to
Mhm.
tell this, since you mentioned this, so as the particle gets detected in the LHC, it is being sent to the computer grid system. They have the huge that
Mhm.
computer grid system, which stores like one petabyte more than the TB, 1 petabyte of information per second. So a
Mhm.
huge storage of data. So they store a huge information. So they make one copy of that, and they say that this information of the particle through like cloud system they share to tier one. They have like tier one, tier two, tier three. So they share to the tier one, whereby all the big scientists are involved, like within the some countries. Then after
Mhm.
that, it is further sent to tier two. Then it's again other countries. Then at last, it is sent to tier three for the local scientists or the scientists who work in detecting the smaller experiment, in doing smaller experiment. So that's how
Mhm.
it they work. It's not that everything is happening in the sun. The main what the thing that happens in the sun is the detection, acceleration, detection. But the analyzing part doesn't remain in the sun only. It involves thousands of scientists all around the world who
Wow.
analyzes, who make use of their theory, whether their theory is correct or not, and they analyze, and that's how they discover the big all these particles.
Right. Quite fascinating. I think I need to go back to the video and then really listen. Some of the things you mentioned, I honestly speaking, it's hard for me to grasp, but I think if the physics teachers are there watching today, I think they will have more idea on what you said. So, like you mentioned, like physics teacher there, they also teach chemistry. For me, I think it
Yes,
will
yes.
be hard for me to teach physics. Yes, I think I don't have any more
I think I
questions
don't
on
have any more
Zoom.
questions on Zoom.
Um,
Um,
there was a
there was
question
a question
from
from
one of the
one of the
viewers,
viewers. Yeah.
and he was
And he was
asking,
asking me,
uh, is there
uh,
also the
is there
creation
also
of
the creation
antimatter
of
at CERN?
antimatter at CERN?
But I think you
Yeah.
already
But I
answered
think you
that.
already answered. Yeah, the Sun is the only place where antimatter is created, and they do it.
Mm-hmm.
They make like anti-proton, anti-hydrogen. So the antimatter of the
Anti-hydrogen.
hydrogen will be anti-hydrogen. Yeah. So they
Mm-hmm.
do produce this antimatter under very high energy, and but since there is a possibility of interacting with the matter, we know that once matter gets in contact with antimatter, then it will annihilate. So that's why what they do is they trap this antimatter using magnetic stripe. Some magnets are used to trap this antimatter to store in low energy, in cold temperature. So that's how they are able to store the antimatter that they have made. And yeah, antimatter, as I mentioned earlier, is already used in medical field, like positron emission topography. So that's
Mm-hmm. Okay.
and
Thank you so much. Yes.
yes, this antimatter that they make is not like a huge amount of antimatter, because to make a huge amount of antimatter is it takes a lot of energy and quite expensive also. So they make a very small amount of antimatter, like anti-hydrogen, but that is quite enough for the medical purpose. Yeah.
Mm.
Mm.
Okay, Savit.
Okay,
Um,
Sabit. Um,
just curious, do they
just
also
curious,
run
do they
workshop
also
for
run workshop
students, for
for
international
students, for
students?
international students? Yeah. So there are some opportunities for the international students. Like there is one thing called Beamline. Beamline for students. One workshop.
B,
That is
is
for,
it
I think,
BEAM?
Beamline. BEAM. Yeah, LIN.
Mm-hmm.
Beamline.
Mm-hmm.
So that is for like, I think, 1 month. But we can also apply. It is open to all the parts of the world. But we have to give should have a proposal on beamline is like we if we are selected we can do the experiment there, but we should have a strong proposal on what you want to find. For example, I want to know about, let's say, muon, how it interacts. So I should have all the proposal written. Then, if we get selected, then the students get chance along with the teachers as a supervisor, and they can then conduct that small experiment in that beamline. So it's
Mm-hmm.
like it's giving students a chance to act like a scientist. Yeah. So that is one.
Wow.
But it is quite tough.
So is it for college students or
Uh,
is it for high school students?
this is for high school student also. Yeah. But there is one for college student. What was it? Solvay. Solvay workshop. That is mainly for the college students, and they can
Mm-hmm.
apply that. Oh, there are two types. No, no. Solvay is for the member state, but they have also
Mm-hmm.
opened one workshop for non-member also. But obviously, and that is for the college students, and the student has to be brilliant in physics and chemistry. And
Wow.
yeah, they can apply. They would be interviewed also. Yeah. So
Mm.
there
So
are
B is
some
for high school students and middle school students as well. They have age limit.
age limit. I think it was 16 years old. I guess. I'm not sure of that,
Okay.
but it's given in the
Website.
website, CERN website. Yeah. So there, Beamline, Solvay, then for the high schools, no, for the college students, that is for member state, and another is for non-member state. Uh, then, other than that, for the teachers, obviously, International High School Teachers Program,
Mm-hmm.
you can apply. It happens every year. And for teachers, as teachers, one more thing is their master class, which they said they can do online.
Mm-hmm.
So yeah, there are a lot of opportunities. Yeah.
Right. I was asking it because I have a student in class 10 and he really likes physics. So I thought it would be a good opportunity if one or two students from Bhutan go there. It will be a good exposure for them.
Sure, sure. One thing I want to tell you is that while going there, along with our International High School Teachers Program, there was summer camp for the students, and there were
Mm-hmm.
students from all parts of the world. And I was just wondering, I wish Bhutanese students
Could get
would
that
be there. Maybe,
opportunity.
yeah, could get, yeah, yeah. And
How
there
long
was
is the
students
summer camp?
from 2 months. Yeah, it's about 2 months.
Wow. Mm-hmm.
Uh, for this summer camp, the only thing is that yeah, most of the member states they get it. For
Mm-hmm.
non-member states, yeah, we have to. I mean, it's quite difficult. But one thing that I saw is these students they get the opportunity to be the shadow of scientists. They will work with the scientists, how the scientists work.
Wow.
They get the lectures from the scientists. They also get the opportunity to do some experiment with them and also involved with the scientists in research. So some of
Mm-hmm.
the students are they did the summer camp, completed their college, and they are now back to CERN working, doing internship or working there only. So it's a big
Wow.
opportunity.
So for non-members, it's quite difficult, like you mentioned, right?
Yeah. So I think through this platform, I would urge our government to collaborate with the CERN, maybe in
Yes.
future. At least if we become the associate member, then there's a huge opportunity for our students who I'm sure if given a chance, our students can also land up there and make the country proud.
Yes, because we need more scientists. And
Yep.
right now we hardly have one or two scientists, and many people
Yeah,
don't know.
right. We hardly have
Yeah.
any scientists or we hardly have done any invention. So it's high
So yes,
time
I
that
think for that
yeah,
our government they need to explore more, like try to become an associate member of CERN, which is hugely going to have an impact on our education system.
right, right. And I think
So yes,
it correlates with our His Majesty's vision also to have the
yes,
STEM as the
globally competent,
global, yeah, right. So,
right, locally rooted but globally competent.
right,
So I
right,
think right now I feel like our it's, education system is more like traditional, and we can't do much, like I said, because of resource constraint. Like in chemistry, we learn about all this analytical chemistry, mass spectrometry, IR. It's just theory
yes,
based, but if it is
right,
in the West, they learn in high school. They do all these practicals by high school. By the time they reach in college, they are already expert in it,
right. Uh,
and it's
I
quite
think
expensive to buy the equipment.
right. I think with the upcoming STEM school, I hope school will get more chance to do a lot of activities, hands-on activities with a lot of facilities. I heard that
Mhm.
there would be STEM schools in Bhutan, so I think that is one of the way to go forward.
Yes, I hope it comes.
Yeah.
So yes, so with what advice would you give to students who's interested in pursuing careers in scientific research, particularly in
Ah,
fields related to the work done at CERN?
yep. So my advice to the students would be curious. Curiosity is must. As a science
Mm-hmm.
student, we should always be curious to learn more and never be afraid to ask questions. Out here, I mean, we hesitate to ask questions, and that's, I think, one of the drawbacks we have in general, not only students,
Mm-hmm.
even us. So
Yes.
that is one thing, and dream big. That's the most important thing, which I tell to my students now and then. Is dream big. It's not only about getting the job. After class 12, you get job and you settle down with a family. That's not enough. You have to dream big, do something for the country, make the country move forward in this competitive world. So it's high time our youth should think that they can do it, and obviously they should have the confidence. They should believe in themselves, and with the sheer hard work and perseverance, I'm sure that maybe in near future we can have scientists and inventors from Bhutan, and that
Yes.
would be a proud moment for all the Bhutanese out here, and obviously fulfilling our HM's vision.
Yes. So that's a wonderful advice. Be curious and then dream big, because there is a magic in thinking big. So thank you for your
Right.
wonderful advice. So I will share this video to my students. So, Sobit, since you've been to CERN,
Yeah.
so are you thinking of pursuing your PhD, something related to particle physics, if you get the opportunity?
Yeah, why not? If I get the opportunity, if I get the opportunity, sure. And I always explore so through these social media sites, and I also tell my students I have shared them certain pages that they should follow. Social media, if we use productively, in a way, we get more exploration, and who knows, we'll end up getting lot of opportunities. That's how I got. Like I got into Fab Lab because I searched through Facebook and even the CERN. So in this digital world, we should in a way allow the students to use, but yeah, productively. And yeah, if I get the chance, then yes, certainly I go for the PhD.
Yes, but I think you already know what you are interested in, so it will be easier for you to choose in what field you want to do, get your doctorate in. So I hope you become like a doctor soon, like get your doctorate soon
Uh,
before settling
I
down.
know. Let's hope for the best.
Yes,
But at
yes.
the
So
moment,
it's mm-hmm.
I'm trying my level best in my small way to encourage my students. Like I want to see this scientists and inventors coming from
Right.
the Bhutan.
Yes, I
So
see. I can already see you doing a lot through your social media. Oh, by the way, I wanted to ask you about this project Panoptis. I've never heard before.
okay. Okay. Project Penetrace, I was introduced to Project Penetrace back in some scholars while doing the master's course, and it was by Madam Ugempe. I think you know.
Mm-hmm.
She's
Yeah,
the
I know
victory
her.
of yeah, yeah. So I was the club secretary, and me and my three friends were selected for Project Penetrace. So how many? Four. So as I was saying, yeah, Project Panoptis basically it is based in Hawaii. So four
Mm-hmm.
astronomers and scientists they came to Samsi College, and we for about 1 week or telescope. So basically, how it functions is it is a remote telescope. Like from here, I can control the telescope, which is now installed in Samsi College of Education.
Mm-hmm.
So, and main use of this Panoptis telescope is to detect exoplanet, the planet which is beyond our solar system, not in our solar system.
Mm-hmm.
And in the world, they have detected like more than 5,000 exoplanets so far. So there is a good opportunity for us Bhutanese. If we detect, then yeah, our name will also come. I mean, Bhutanese. We will get the chance to name the star also. So that is one of
Wow.
the aim of the project benefits.
Mm-hmm.
And we also we made in the I mean it's installed in Samsi College. Then I and my friend also helped building the robotic telescope in Royal Academy, Panglisa. So all the basically class 11 students they were engaged in making this telescope. So we were also part of it. I mean, we helped. A little bit.
Wow.
So
Mm.
so that is also one of the opportunity that
Right.
even the
Quite
students can try.
fascinating, right? Yes. So that's why, like I said, collaboration is really important for
Yes.
our students to give more exposure, like bringing telescope and all.
Right.
And Sobit, I saw through your social media in your STEM club, like your children were building robots. And how do you get that resources? Is someone helping you?
Do you mean the car one? Which one?
Not sure, but you were doing with all the software and all.
Oh,
Did you explain on your
okay.
own or?
Okay. Oh, that one. It was my own expenses. So the
Wow.
Arduino thing. Yeah, yeah. So I was interested in that. So yeah, I purchased myself, and because we do not get all this
Online?
stuff.
Through online?
Yes, yes, through online. Yeah, through
Amazon and all.
yes, Amazon, Flipkart. Yeah, through that one.
Wow. Mm.
So I wish if we can have more of such, like for example, Arduino. So that's for Arduino, so whereby we just easy coding so that we can make many science prototypes. So in Bhutan, if you can have such kind of stuff in all this in most of the schools, and what I think is like STEM club. I initiated and formed a STEM club here, but I feel that STEM club should be in all the schools, and I wish that STEM club, uh, in a way, it sparks curiosity among the students, and through that I come to know that students get engaged so much. They want to build something, not only learn theory. So I think
Mm-hmm.
that's the way forward. I mean, that's what I think the education system should work on. More of making
Then we
prototypes,
need
more of
resources as well.
yes, yeah. So I think that can be done through collaboration with other countries.
Right. Yes. So finally, Sobit, what advice would you give to educators on how to continue growing and effectively support students interested in STEM fields?
Okay. Uh, to all the educators like me, do not what I in this 7 years of teaching career, what I found out is just don't wait for the opportunities from the
Hmm.
government or yeah, just explore. Open your Facebook or whatever social media. Try to explore, learn each day, whichever field you are interested in. And yeah, these days the teacher has to be content creator as well. That's what I think in a good way. Like you are doing well as the educator. I think we should also make some content which will spread knowledge not only to our students but all parts of Bhutan or maybe international also. So through that we get more exploration, more exposure, and there's chance of getting collaboration, networking with the other countries' teacher also. So I think in this digital world, we should make use of it. And in this AI, I'm taking, I mean, taking interest in all these new technologies. And in my free time, I watch a lot of videos and I try to learn a little bit. Though I don't know much, but a little bit I try to learn what AI is, or how to use the machine learning, what is it, how it can be helpful. So in that way, I think the main key thing that I want to say is we should explore more by ourselves. Just don't wait for the government to do everything. So that's the key thing, I think. And sorry, what is it? The next one?
Yes, basically, yes, that, I think you answered the questions.
Ah,
Yes.
explore
So I
and
got
yeah.
a, I think there's a student, I think your student who said, Sobit sir as an epitome of true and hardworking teacher lost,
Oh, he's my colleague.
which I believe. Colleague? Okay.
Yeah, right. Yeah.
Right. So I think
Okay.
yes, what your colleague mentioned is true. I can see through your content, your STEM club, and all this. I think you're doing a fabulous job, going beyond teachers' duty and exploring and also getting opportunities.
Yeah, thank you. And even you are doing a great job. Last time I showed your videos to students, and they are
Yes.
inspired. So
Actually, I always
keep it
wanted
up.
to create a content
Yeah.
like in TikTok, usually Bhutanese, if you see content, no, they try to copy someone's singing or dancing style, and there's nothing new. And then we absorb all these things which does not really help us.
Right. Right.
I have Instagram account where I read and post reviews,
Yes.
and then I realized that people actually don't have time even to read reviews, but then I was really shocked when I saw when I posted the video, and then I got like 18.k something likes. And then I was
Yes.
quite shocked to see that there are so many people on TikTok who's watching all these videos. Eh?
Right.
So yes, so I think one way to reach the audience and to encourage and inspire them is through videos, because people like to
Right.
scroll through TikToks. So that's
Yes.
my goal, but I'm still trying to get time to create content. So whatever I have learned through books,
Yeah.
I'm trying to make it into video content. So let's see how far I can go.
Yeah. You're doing great. Keep making the content. Even I try to make, but still I'm in a learning phase. I
Yes, so I follow and then yes, follow your page, and it's quite fascinating. I think I'll ask my colleagues to follow your page, especially the STEM club coordinator here.
Yeah. Thank you.
Yes. So yes, so I don't know if there are any more questions from the audience. So basically, I would like to end by thanking you for sharing your valuable insight and
Yeah.
for taking the
Uh,
time to speak with us
um,
today. So your work not only sets a remarkable example, but also has the potential to inspire many to explore opportunities like the CERN work, like you mentioned. And we hope your achievements encourage others to pursue similar paths and make a significant impact on the world of science. So thank you once again, Sobit, and then
uh,
inspiring and keep making beautiful content. Thank you,
yeah.
and
Thank you
then
so much.
let's.
Yeah. Yeah. Thank you so
I
much,
hope you
Ricky.
get
And
1,000 followers so you can we can see your face
yeah,
next week.
but I hope by now, I think, yeah, I think my followers, it will increase. Then we can have another.
Hopefully,
Yeah.
I also don't have many followers. I just reached 1,000 mark, and then I thought of you. Why not I go live and encourage
Yeah.
other educators? No?
Yeah. I would like to thank you for taking this initiative. Uh, you are the first one. Back then, when I went to Sun, also you were the one. We are the first one to share my.
Yes, I
I
was
mean,
really
went to,
excited.
yeah. You are the first one. Uh, I got a lot of wishes and from the friends and others, and taking this initiative, inviting me as a guest, it means a lot. And I hope now in Bhutan, the teachers, this teacher and others also, I think they have got some knowledge about sun, though I am not expert on it. But I hope in through this podcast, they might have got some curiosity to learn more about,
Yes, that was actually my intention to reach educators so that they can explore more and share their knowledge to the students.
Right. Okay, thank you so much, Vicky.
Thank you, Sobit. Thank you so much, and